The broadcast is now starting. All attendees are in listen-only mode.
Welcome, everyone, to another DevOps.com webinar. We're lucky today to have a couple of distinguished people with us, Rosalind and Suman from IBM, and they're going to talk about application discovery, and specifically with enterprises. It's very interesting, and I think it's very informative, and I've learned a lot, and I think you will too. With that, Rosalind, why don't you talk about yourself a little?
Thank you. So I'm looking forward to today as another opportunity to demonstrate what the possibilities are when you can really understand your applications. So as was said, I'm Rosalind Radcliffe. I'm a distinguished engineer in IBM, and I'm responsible for our DevOps for Enterprise Systems strategy. For those of you who might not know me, I've been in IBM about 30 years, just over, and I started in ISPF development and have done numerous things since. With that background, I've spent a lot of time dealing with the various applications that customers have and have seen how development has progressed over these 30 years. And so as we go through here, I want to point out how the way we've done development for all these years can now be improved with a better understanding of our applications and allow us to take those assets that we have and provide even more value to the organization. As we go through here, a little later, Suman is going to show you a demonstration of the capabilities so we can really drill into this. So let's move to the next slide. I wouldn't be Rosalind if I didn't start with a slide on DevOps. And really, there's a good reason for this. DevOps is the transformation that's going on in our industry that allows us to take advantage of this digital economy. We need to be able to move at a speed that is significantly faster. We need to be able to work together across the organization to provide the business value. And in order to do that, we really have to change the culture. We have to change the processes and practices, and there's a set of technology that can be used to help facilitate this. DevOps is a key way of working. It is a way of allowing your teams to work together. It allows you to deliver the value you need at a much faster rate. And if you think about a definition of DevOps, it's really all about lean and agile, bringing them together across the entire organization, from the business all the way through the development and operations organization. And everybody has to work together. In this picture, you'll see I actually have the Blue Mix Garage method diagram, because it doesn't matter if you're building enterprise systems, you're building a mobile application, or you're doing COBOL. All of those practices, the way of doing development, should be the same and should be consistent. There may be some differences in the tools we use. I need an editor that understands COBOL, or I need an editor that understands Java. But other than that, we need to bring our teams together so that we can deliver this value at the speed required. Next slide, please. The other thing we need to look at is that we're going to be in this hybrid world. We're going to have systems of record, we're going to have systems of engagement, we're going to have systems of insight, and they're all going to have to work together to have teams collaborating to build value for the organization. Think about the Ubers of the world. They are transforming the way we think about being a business. And honestly, a few years ago, when somebody said the Ubers of the world, I said, well, that just doesn't really apply to banking or insurance. And then it happened. Someone built a bank that was all IT. There was no back-end insurance or any of the other requirements because they used APIs provided by an insured bank. Think about that. It really doesn't matter what industry you're in. The IT world, this digital disruption, the API economy is changing that. And if you look at this diagram, you'll see all different parts of the application have to come together to provide this business value. And in my diagram, I'm showing the pictures are identical for a reason. Doesn't matter that the back end is a IBM Z system running COBOL, running your back end business value, and your front end is an iOS application or Android Studio development. It doesn't matter. They all need to work together, and they need to have a common set of processes and tools. Next slide, please. All this allows us to work in this new API economy. This new API economy basically says, I need to expose my business value as a set of APIs that allows developers and others to bring those services together to deliver new business value. Now, in some cases, that's going to be internally. You're going to be building a set of APIs that your internal teams can bring together to provide new business services. But it also may mean that I'm exposing these services externally so that new businesses can be formed. And they're using my business APIs, so that's valuable to me. So think about that. You can have a whole new business that's just run because I expose a set of APIs to the world. But we have to think about this a little harder. Where are those business services today? They're sitting in our systems of record. Our systems of record many times are very large systems that may have been built over the last 30 years or longer in some cases. That code contains all your business rules and your business value. If you think about that, do you really understand how those systems really work? Or are they, in many cases, large monolithic applications that you're in some ways afraid to touch? But you have that business value in it, that customer record, that account calculation. All of those things could be provided as services. The trick is to figure out how. And then once you expose those services, then you can compose them together. I also want you to think about the fact that there are probably multiple layers of these APIs. I'm going to have a set of probably internal IT related APIs that provide a set of underlying services that will be put together and exposed as business APIs externally so that they can drive this business value. Those external APIs need to be managed, they need to be monitored, they need to be metered. But think about it, those internal services probably need similar function as well. You need to track who's using which services, who's using which versions of which services. We need to make sure that everyone that's using the services is tracked, monitored, and they can be metered. This allows you to easily manage these services and provide the appropriate chargeback system within the organization, if that's how you wish to do it, as well as provide the appropriate charges to external users of your APIs. If you think about this, this could mean your IT organization is actually a new provider of real income to the organization through these provided services. But how on earth do you take this existing application and turn it into these services? How do you take the function that you have and turn it into what you need? Well, you need to understand that application. And that's what we're going to go into next. We're going to take a look at a sample, a way of looking at your existing assets and turning them into APIs. So Suman, let me turn it over to you for a demonstration of the capability.
Thank you, Rosalind. I hope everybody can hear me. I've just unmuted myself.
Yes, we can hear you fine.
Okay. So thanks, everyone. I am Suman, and I work as a solution architect for ADDI and DevOps on Z. And I have been an application developer for a number of years before I moved into DevOps, initially automation and then DevOps. So to continue from what Rosalind was talking about, how it is the current, the business logic of exposing, of what the business logic, what we want to expose as APIs, they exist in the enterprise applications which are on System Z. So how do you really know what you can expose as an API? So this chart kind of shows you how, or it gives you a very high level idea of what goes into exposing something as an API. So if you have your Z system applications and you know what you have, you know your applications very well, you know them in and out, you have defined interfaces, which means you have a presentation layer, you have your business layer, you have your data layer, everything is very well defined. Then you can easily expose your business layer as an API with something called ZOS Connect Enterprise Edition that IBM has. So ZOS Connect can take a copybook and then convert it, and it has easy tooling which helps to create JSON schemas out of it, and the actual runtime of the ZOS Connect, it can sit on your mainframe, and it can convert your program, or rather it can act as a link between your program and expose that as an API to the outside world. And this API is an open API standard format that can be consumed by anything and everybody, right? So this is the ideal situation where you know your applications, you absolutely know where they are, you know that your applications are very well defined, and then you go and expose them. But unfortunately, it's not always, or rather most of the time, you really don't know what you have. So unless you know what you have, how do you know what to expose as an API? And that's where application discovery comes into the picture. So if you look into your entire digital transformation journey, you first need to understand your application, and then you need to expose them as APIs. Now, it is possible that you, even though when you understand your application, you might need to actually refactor them, separate out the business logic and your presentation logic. So there are ways to do that. But for this particular webinar, we will talk about how application discovery can be used to understand these applications, how you can easily come and identify the exact program that can be exposed as an API. And to do this, we will start off with a small scenario. So in this scenario, we talk about an insurance company, which is AXY. Now, the AXY insurance company has multiple applications, and Sue works with the business development team. Now, Sue is always looking for ways to turn around claims processing, so to enable the business operations to actually process claims much faster. And she believes that mobile enabling applications, digital transformation, this is the way to go. And she also thinks this would really help operations increase their response time. So what Sue does is she raises a business requirement with the IT team and say, let's mobile enable the customer inquiry screen to start off with. And she wants to get this done for almost everything, right? So that's what Sue does, and she raises a requirement with the IT team. So moving on to the next persona, you have Dave, who is an architect with GenApp, and GenApp is one of the applications at AXY Insurance Company. And GenApp deals with customer data, inquiries, and some amount of claims processing. right? So Dave's application involves a lot of mainframe legacy screens. It's got a little bit of web services. And at the moment, he's trying to explore how Java developers can effectively get data from the mainframe, because the Java developers, they love to get data in the form of APIs. They find SOAP very cumbersome. So there's always this little bit of disconnect. And when Dave receives a requirement raised by Sue and says, and he knows that he has to, there are some green screens that need to be converted, he thinks, yes, now this is my moment where I can actually expose this as an API, and the Java developers can easily use it and in their mobile app and in their tablets and the mobile interfaces, right? So Dave receives a requirement from Sue, and he decides that he'll use ZOS Connect to create an API out of his existing business logic. So then Dave goes on to Joe, and he tells Joe that, you know, you have to create an API, and this API is for the customer inquiry screen, right? And he also tells Joe that you can use ZOS Connect to create the API, but you need to know where to create the API from. So Joe knows that he has to create an API for the customer inquiry screen, but he doesn't know which program can be exposed as an API. He doesn't know how it can be exposed. What is the interface structure, etc. So what does Joe do? So Joe has the following objectives, right? So he needs to first identify the customer inquiry screen. Now, he doesn't know there are lots of screens in GenApp. He doesn't know what to do. So he has to identify the customer screen. He has to understand the transaction flow. So once he identifies the screen, he has to know the flow of the transaction. And then from all those programs involved in a transaction, he needs to identify a couple of candidates that can be invoked via an API. And not just that, he needs to find out what is the exact interface structure, because that is what ZOS Connect as a product needs to start with creating an API, right? So with these thoughts in mind, let us go on to application discovery and see how Joe can actually go through and identify and go through and complete his objectives, right? So to identify the customer screen, understand the transaction flow, understand the candidate program, which can be invoked by an API, and also identify the interface structure. So at this point, I have moved into application discovery. I'll just give it a minute so that the screen actually moves into application discovery. So hoping that everybody can see my screen now. What you see here is IBM developer for Z Systems, IDZ, or what was earlier known as RDZ. And application discovery sits as a plugin to IDZ. So for a developer, he can continue developing his coding, unit testing, everything within IDC, and he can quickly switch over to application discovery to do his analysis. This is Eclipse based, so it basically sits not just on IDC, but on any Eclipse product. So when Joe as a developer logs into his IDZ and his application discovery, what he sees is a list of projects that are available. So these projects are logical groupings, and it consists of application code that has already been analyzed and populated into repositories. So for Joe as a developer, all he needs to do is he needs to go to his particular application and run graphs and reports, because it's already analyzed and made available to him. So going back to our scenario, Joe needs to know what is a screen that does customer inquiry. So how does he do that? Now, he doesn't know anything. Let's assume that he doesn't know anything much about GenApp. So what he can start off with is he can do a search. So Joe invokes a search. He wants to find out what is a screen which does customer inquiry. Yeah. And for this search, he has to only select the screens, which is the BMS maps, and run a search. So the search brings out few results. The first thing itself says, yes, it is the customer inquiry and there's a customer menu. So he gets the exact map, or rather the screen in which there is in which customer inquiry is made, right? Using which the customer inquiry is made. So now Joe has identified that this is a screen which is used for customer inquiry. So what he can do now is really something quite amazing. So he can actually go into the screen, something known as a screen call graph, right? So at this moment, he's going to invoke the screen call graph. So he knows the screen name is map C1. He selects this particular screen and runs the call graph. So what this does is it invokes all the relationships that the screen call graph has, the invoking program, the transaction, and it traces everything all the way to the database. So what Joe essentially gets is all the programs involved with the inquiry screen. Now, he can confirm that this screen is indeed the inquiry screen by quickly seeing the screen layout. So this, remember, this is a BMS map. It's written in BMS macros. You have to either run it in CICS or you have to go in and try to read the DFH, MDI, what you see below. But because AD can quickly open up these screens, he can see for himself that this is the customer inquiry screen and this is the right screen that he has to analyze. And looking at the graph, he sees all the programs that are involved in that screen. So he sees that, I'm just going to zoom it in a bit. So he sees that there is transaction SSE1, which is responsible for invoking the screen, and the main driver program is LG test C1, right? So now, among all these programs, how does Joe identify what is the right program for a customer inquiry? Now, there are many ways to do this in AD, but one of the ways could be to start from the database. So we have the customer database right here. So let us try to work backwards and see what is the program that does a customer inquiry, or rather selects. Now, because I know AD quite well, I can, to understand the different colors and the different annotations, there is a small legend here which tells us that, you know, anything blue is a COBOL program, and then you have a database here and what all these lines mean. So the red line means a dynamic call and so on. So with this, I actually know from the lines, because I'm familiar, that anything that goes into the database is modifies the table, and anything that comes out is actually an inquiry, right? So if I click on this arrow, what you see at the bottom left over here is that there's an SQL insert happening. And if I click on this arrow, it tells me that it's an actual SQL select. So without even going anywhere, but with just looking into the graph, Joe can easily know that the program that selects from the table, and therefore the one that does the customer inquiry, is LGI CDB01. So if he can even double click on the line, and when you double click, the actual select statement pops up, so he can even go through and see what the exact select statement is. Now, he could also do this in a different way. So for example, he could always run something known as an SQL table usage, right? So what if this table had multiple arrows going back and forth and you wouldn't really know what was doing a select? So he could run something known as an SQL table usage, which would tell him what are the exact programs that select from the customer table. So I can just do a reorder. I want to know by statement type. So I want to know what are the programs that select from the customer table, right? So I just reorder the results, and from there, Joe can still know that it is LGI CDB01 that selects from the table. So then, so as you see, there are multiple ways to get around ADDI. So you can directly tell from the graph what is a program that does the inquiry, or you can even run usage reports to get the same information. Right, so at this point, we know that LGI CDB01 is the program that selects from the database. Now, there is quite a lot of information. So let's just try to make it simpler for Joe. So he wants to now trace only the inquiry flow. So he wants to know that when a select happens from the database, how does an inquiry flow look like? So for this, there is a very simple functionality that ADDI has. So you can say, hide all my edges and show filter only those programs that are backward and hide everything that is not connected. Right? So you have some filter functionality within ADDI that helps clear up. And with this, what Joe can actually do is he can find out the exact flow of the customer inquiry. So with this, Joe can find out the customer table is read by LGI CDB01, which is called by LGI CUS01, and which is in turn called by the main driver program. So so Joe has not only identified what is the screen, what is a transaction, what is the entire transaction flow, but he's also managed to isolate just the inquire flow. And that's what he wants, because he now knows that one of these programs in the inquiry flow is the one that he has to expose as an API. Right? So if you contrast this with a traditional application where you have, looking at this, you have at least about 7-8 programs, and you have to go through every line to understand what the transaction looks like. You have to go in to every program to see what's the other program being called, which is you have to run separate searches to understand which programs call the database. So there is so many manual work involved, even for a small, simple transaction like this. So imagine in a real life case where you have a transaction which calls a number of programs, the amount of manual work just increases. It increases like tenfold. So a diagram like this, which helps you really identify, isolate flows, helps you to narrow down your analysis to what you actually need to do. Right? So coming back to analysis, there are 3 programs in the customer inquiry now that we've seen. Now, in this particular case, the first program is actually invokes a map. So you cannot expose this program as an API. The other options are for Joe to expose either LGI CUS01 or LGI CDB01. So these are the 2 options that Joe has. Now, it is always prudential to expose the program that is closest to the screen interface, because that tells you that it is closest in functionality to the actual screen. But to be sure, what Joe can do is he can invoke the program flow graph. So when he invokes the program flow graph, he can understand the program functionality. So he can understand what is it that the program does. So if at all he has doubts on which program to invoke, he can go through the program call graph and reconfirm that which is a program that can be exposed. So if there is a program, let us say LGI CUS01, which does some additional logic in addition to just fetching the tables from the database, then you would need to expose that as an API, because it makes more sense to expose a program that has enough business logic in it, right? So at this point now, Joe can identify that it is LGI CUS01 that can be exposed as an API. So lastly, now to expose it as an API, he will also need to identify what is the copybook or the interfacing structure that can be used. So to do this, you can just, again, use the same graph and understand by double-clicking on these lines, he can drill down and understand how exactly the driver program calls this business logic program or any other program that you've identified to be exposed as an API, right? So in this, you see that it uses a COM area. Now going into something known as a COBOL variable usage. So this is a COBOL variable usage. Joe can search for COM area. So he does not have to open the code at any point. And now he knows that this is a copybook or the interface structure. He can actually query the interface structure. He can double click and he can know that he can understand that this is the, these are the fields in the interface structure. So he can even drill down to the exact interface structure of the program that has to be exposed as an API, right? So what we have now done is, knowing just that we have to analyze the customer inquiry screen, Joe has gone in, run a search, and identified what is the screen. He has identified the transaction which invokes the screen. He has identified the entire flow of the transaction. He has isolated the inquiry flow, and within the inquiry flow, he has easily identified which program can be exposed as an API. And in addition to that, he's also found out what is the interface structure that can be used for the API. So this kind of completes what Joe's objectives are, which is identify what can be exposed as an API. Now that Joe has identified it, he can easily create an API out of this. He can use EOS Connect, which has very easy tooling and which helps him to create quickly a JSON schema. It helps him to map the COBOL copybook with the JSON schema and expose this program as an API, right? So this is how application discovery can easily help you understand your program and let you know what are the different candidates which you can expose as an API. So we've now identified the RESTful interface, and ZOS Connect can now be used to create the API. But a couple of scenarios. So what if the program was monolithic? So which means, what if all my logic was within a single large program, right? So what can you do? So in that scenario, what you could do is run a program call graph. So I have right here a modified Gen app, which has a program, the driver program invoking both directly the database programs, right? So going into this modified program, in our case, we have a little more complicated. So we have, in this graph that has shown up, we have this database program, which is directly invoked by the driver program. The program that reads the database is directly invoked by the driver program. So in this case, what do you really expose as an API? So how do you understand? In other words, if you have a program with a lot of logic written in it, how do you understand how to split that logic up so that you can expose it as an API? So like I've shown in the earlier demo, we can invoke the program call graph, the program flow graph, and drill down further. So this is the program flow graph. So you can actually drill down further into the program flow graph. You can identify what is the required paragraphs. You can understand the paragraphs and select the required paragraphs. You can select the paragraphs that lead to the database invocation, separate them out. So with the program flow, with the program flow graphs, and also with something which is the program flow chart. So this is what you see on the screen is the actual flow chart of the program. What you can do is you can identify portions of the code, and you can identify that these need to be probably refactored into another program and then exposed as an API. So what ADDI helps you do is, even if you have a large code and you have to refactor them, it helps you drill down to the exact paragraph that can then be refactored into maybe another program, and that program can be exposed as an API. So if you have a monolithic program which has a lot of logic, you can still use ADDI to identify which paragraph, which portion to extract. Now, what if you just want to find out what, on a general note, what could be my potential API candidates? So application discovery actually has an entire database. So the application discovery product sits on an SQL Server database which can be queried, and you can write custom queries on this database. So all these custom queries can be run using something known as rules-based analysis. So using the rule-based analysis, you can write your own query and run reports out of ADDI. So for example, some of the reports that are useful, maybe in identifying API candidates, are show me all the programs that are invoked by the presentation layer. So for example, if you have all your screens which are called by a driver program, which invokes only which does only the screen processing, I want to know all the programs that are invoked by the screen layer. So to me, they could be potential candidates because they are the ones which directly are invoked by the presentation layer. So I can write my own rules like this, or let's say, show me all the programs with rules and policy. And maybe that will help me understand what is the program which has maximum rules on policy, and maybe that is a business logic that I want to expose, right? So I can write my own query that will get me programs with rules and policy, and I can run these reports. So a sample of what these reports look like are here. So I'll just give it a minute. So what you see on the screen is a report of programs with the number of rules on policy. So if you look at this program LGI PDB, that has the maximum number of rules on policy number, and you have the list of what different kinds of policy variables that are available. So like this, you can actually write custom queries to to suit your application to actually pick out candidates that can be exposed as an API. So these are different kinds of ways by which application discovery can be used or can be enhanced to identify potential API candidates, to understand your application, and so on. So these are some of the features of ADDI that we really wanted to show to help you realize how important an application discovery product is when you decide to go on a digital journey, or when you decide to expose your system of records as an API. So that's it from a demo perspective.
Hey, Suman, thank you very much.
Yeah, I'll hand it over back to Rosalind. Rosalind, if you want to continue.
So I think I'm noticing questions that are appearing in the chat and in the discussion set. So I think maybe we'll turn it over to some questions first.
That's a great idea, Rosalind. Well, I'll ask you the questions as they've appeared, and you all can decide who should answer them. The first question, but how do we deal with the monolithic applications? How can I see the functions? But if it's hidden in the existing mess of applications, how do I actually expose the capabilities?
Yeah, so we sort of demonstrated a piece of that by showing an application, a more monolithic version of an application. But you're right, many of your large applications are highly monolithic. They do have screen calls, they do have a set of things all mixed together. And so you can use ADDI to understand that application, understand that flow, and then you have a couple of choices. One, you could refactor that application. So you could pull out the piece of the application that has the function that you need. Or if you go through that application, you may discover that at the core you have a transaction that you can call directly, even though it's mixed into the set of things. So you need to look at what you have, and by using application discovery, you can understand the program flow, you can understand the pieces, and then you can make the choice. But there's another piece to this answer, and really, as you transition to more automated testing, as you bring in automated testing, if you have a set of automated test cases that allow you to test this set of functions, then you can more easily refactor or pull out that code. If you don't, what many organizations are deciding to do today is pull out that function, but leave the application whole. So in a sense, not really pull it out. Leave the traditional application the way it is to run the existing business, and make a copy, which does mean you have a copy and you have to track the fact that you have duplicates. But you could then make a copy and not affect the existing business systems, but then expose this. Each choice has its own benefits and its drawbacks. The more that you've moved to a DevOps pipeline, so you have the automated testing in place, the easier it is for you to refactor, the easier it is for you to do the cleaner way of pulling this out. But we have seen customers, just make a copy so that they have a second version that doesn't have all the screens in it to allow you to expose it as an API.
Great answer. And here's an interesting one. We started this conversation with DevOps, but the question is, how does DevOps really help with the API transformation? What is the value it provides?
Yeah, as I started to say, if you have a DevOps pipeline, then you have automated testing in place. Think about a DevOps pipeline as a way to allow you to fully regression test your existing capability in a way that you're comfortable. So you may not be testing 100%, but you're testing enough to know that you are not breaking, you are not messing up your existing applications. By already having that pipeline in place, it's so much easier to refactor existing code, pull out the pieces that you want to expose as business services, and understand that you aren't messing up your existing structure, you're just bringing new value. It also makes it easier for you to do this faster. You have an automated pipeline that allows you to run a change through the system to see what the impact is, to see if your change is going to cause a performance issue or take your choice of kind of issue. It gives you more flexibility, and it gives you more confidence that you can make some of these changes without causing disastrous effects or without causing any impact in many cases at all.
That's great, because you have a staging area, saves you a lot of worry. Here's one interesting one. Does this process deal with non-SQL data stores, such as IDMS, IMS, ADDI, etc.?
So the answer is yes, but I'll let Suman answer all the different things it supports.
Yes, so yes, IMS is yes, IMS database, ADDI as well as IDMS, yes. So it does, AD does support these databases, but to various different levels, yeah.
Oh, that's great. Do these tools handle software outside of the vanilla COBOL, CICS, DB2, etc.? What about IDMS? Oh, we already asked that, and Easy Trees and all that. But basically, does it handle software outside of the vanilla standard software?
Go on, Rosalind.
No,
yeah,
go ahead.
Yeah, so AD can handle COBOL, PL1, assembler, and Java to the extent of identifying the interfaces to the mainframe. So it is basically a mainframe analysis product, but it can analyze Java just to the extent of finding out what are the interfaces to the mainframe. At the moment, EasyTreeve is not supported at the moment, yes.
Okay.
I think to add to that, I think it's important to recognize that the intention of application discovery is to understand your existing mainframe code to be able to hook it to the rest of the world or to expose it to other pieces. And it's in use in many large-scale organizations. It not only understands those language types and programs, but it also reads information from the system. So it is a source code scanner, it's a static analysis tool, but it also queries the system itself to get an additional set of information, including information from your job scheduler. So if you think about your applications, in many cases, things are kicked off out of the job scheduler that may impact the way things work. They definitely impact the data in the system. And so it also gets information from the system itself so that you have a better picture of your overall application flow. It's not just a static analysis, it is also a system understanding.
Mm-hmm. A lot of people have been asking if we can get a copy of the slides or a replay. Don't worry, everybody, within 24 hours you'll be emailed links to both those. You'll be able to see a replay as well as access to the slides. The next question is, how hard is it to get my applications in? And the applications, does it handle more realistic applications that are very large? Relating to ADDI in the beginning, and how does it handle large applications?
Yes, so there are multiple ways to get your applications in. You can bring your source code out into a Windows folder and then feed it into ADDI. So ADDI runs on a Windows server. Now, but the best part of ADDI is that it has got hooks which can go into your source code management system. So it can go into ChangeMag, can go into Endeavor, pull out your source code, and it can then do its analysis. So it can go into, it can also go into your CICS, MQ, DB2, bring in data. It can access your CSD, CICS, CSD files, and it can ingest all that data. So yes, it goes into the mainframe and pulls out the source code. That's, I think, the first part. The second part, there have been extremely large implementations in many of our customers. So there are customers who run end-to-end. They have all their source code on ADDI. So yes, it can process an enormously large amount of data.
So I need help here. What is the difference between AD and ADDI?
Rosalind, you want to go?
Sure.
Okay.
So if you think about what we've been talking about, we've been primarily talking about the application discovery part of the application discovery and delivery intelligence capability. ADDI is a bundle, in a sense. It is a package of the application discovery capability that formerly was known as EasySource. So we acquired the EasySource company and have continued to work with the system and solution and continue to evolve it and rename it, of course, because IBM acquired it. We have to rename it and called it Application Discovery. But we also took our application delivery intelligence capability and have it together with the application discovery capability in order to complete more of the pipeline capability. So we're providing a set of insights based on testing and based on system performance. So application delivery intelligence, you can feed your test case results with code coverage. You can feed your Omegamon data into the system, and it can give you understanding and insights as to whether or not you are, running unnecessary tests, Are you running the right tests when you make a code change? And the two, over time, we will evolve to add additional capability. And that's where we'll get our cognitive DevOps capability. So you'll see even more insights coming into this product so that you can drive your DevOps tool chain in a more cognitive way. So you can really understand how to improve, what you need to run first. I know many people, their regression bucket over time starts to get very large. And so the question is, what do I test first based on this code change? And using application delivery intelligence, it can help you select, these are the tests to run first to get your feedback back to the developer quickly, and then continue down the pipeline to continue to run later tests. So there continues to be improvements in this area to continue to drive additional insight into the solution. But we did bring these two together because the combination as part of your DevOps pipeline helps improve your overall processing of understanding your application, as well as improving the testing and performance kind of application understanding.
Okay. I have a few more left, and then it looks like they're about stopped. But can ZOS connect directly expose to programs input and output copybooks as an API, or does it have to go over a transaction? Does that make any sense? Hello?
Yeah.
I'm just thinking.
I was wondering.
So,
they're getting pretty deep here, some of these questions. People out there obviously know something.
Yes, so I'm just thinking. So if you have, ZOS Connect works not just on CICS, but it can also expose IMS. It can directly expose your DB2 programs, and even in fact batch. So to answer the question, it does not. Well, I don't think it necessarily has to be a transaction. It can be a program in CICS that can be invoked. So if you have a program, a background transaction program, so I assume that when you mean a transaction, you mean there is no screen-based interface, and you have just a background transaction running. Yes, that program that runs as a background transaction can be exposed as an API. I hope I got that question right.
I think you did. Everyone realizes the contact information will be available. We'll make that available to you, and you can get further questions and inquire further with the speakers here directly if you'd like to after the presentation in the following week. The questions are getting very good. They're getting very deep. It's very interesting. Brings me back to my old mainframe days. Is this an application or portfolio? All systems analysis portfolio just on mainframe? Will it be 1,000 applications? Does that make sense? Let me see if I read it right. Is this an application or portfolio systems analysis?
So this is going to allow you to look across all of your applications. If you noticed in the demo, Suman had a number of different applications that were scanned, and you would logically scan all of your system applications, all of the applications that you have in your organization, to pull them in to understand all of the pieces that you might want to provide value with. So it really is intended to give you a view of your entire organization's portfolio from the standpoint of understanding all of the applications within it. But you did see that it was application by application, but I'm going to be cautious in this. You determine what counts as this application. So it doesn't have to be an application per se. If two parts of an application or two different applications are highly intermixed, you may actually bring them into the system as one application because they really fit together. I know I work with one client who has what I would call an application that is really 5 applications, and they will bring that in as a single application in ADDI. So it will come up as a single application because they want to understand all the dependencies in it. But I believe all the organizations that are using application discovery are using it across their portfolio, not just for a single application.
All right, great. I think I have one more. Does source code have to be moved from production source libraries to somewhere else?
So application discovery can read it from the existing system, and logically you may or probably want to read not just production, but you want to read the development environment as well. Depending on how you have things set up, you're going to hook it into your existing source code manager, and so it can get it from the existing source code manager to be able to feed application discovery the information. So you're not in a sense having to copy it somewhere else to get it to application discovery. It can pull it from your source code manager. If you are not using a source code manager, which you should be, but if you're not, it can read just from PDSs on your system, and so it could pull from whatever set of PDSs you wish to pull it from.
Now, these are some great questions. I mean, I'll take one more, and then we'll sort of move on with final thoughts. If scanning for a specific variable across programs or applications or portfolios, does ADDI do a context or fuzzy search to get permeations of the search?
Can you just read that question once more, please?
I know some of them they're pretty, it's great. If scanning for a specific variable across programs or applications or portfolios, does ADDI do a context or fuzzy search to get permeations of the search?
Okay, so I think I will take the question in 2 ways. So you can now, when we did a demo of ADDI, it wasn't all the features, it was just the features specific to APIs. So you can run an impact analysis on variables, on whatever, you could be a database variable, it could be a copybook variable, a program variable, and ADDI can trace the exact flow of that variable through the various programs. It can do a backward as well as a forward. So it can do that. It's not just a search, but it actually traces the flow of that variable through programs. So that is something that ADDI can do.
Okay, great. Well, I'd like to thank everybody for all the great questions. They obviously had a lot of thought put into them, and I'd like to thank our 2 speakers, Rosalind and Suman. Do either of you have any final thoughts?
Just in closing, I want to say it's very important for all of us who are doing anything related to our ZOS systems to really understand what's there and to allow our businesses to take the best advantage of those assets. And so I highly recommend you go read the DevOps for Dummies books that have been written, including the latest one, APIs to Z Systems for DevOps for Dummies. So they help you understand how the mainframe really has to be part of this and how the transformation is going on. We need to make sure that companies are taking advantage of those assets that they have and not losing the value of them because they're afraid to change them. So learn, explore, go out and try the Z trials so you can play with this yourself. Those links are available. And if you have questions, let us know. There are lots of ways to get a hold of us. We have our contact information, or you can always find me on Twitter or LinkedIn, and I'm happy to have further conversations. So thank you for your time, and go out and play and enjoy.
And I think that's a great way to end this webinar. And thank you everyone for joining us, and have a great rest of the day or evening, depending on where you are. Goodbye.